This is the prep packet for Unit 4, Chapter 9.6. This is Objective 1, and this is the video for the second part, Part 2. So what we were working on before was rationalizing radicals in the denominator. And just to review, the idea is that you don't want to have a radical in the denominator. And to get rid of that, you need to multiply it by whatever it's going to take to make it a whole number. So in this case, it's the square root of 5, and I would multiply it by the square root of 5 to get 5. And what I do to the bottom, I do to the top, or the denominator and the numerator. So I would end up with 2 times the square root of 5 over 5. Remember, if you get to the point where you have squares under the radical, make sure that you simplify and pull those out. You can also simplify your fraction if necessary. So let's take a look at this. Here we have the square root of 6 in the denominator, so I'll multiply both parts by the square root of 6, and I'll end up with 7, and the square root of 11 times the square root of 6 is the square root of 66, and that will be over 6. And remember, there's no perfect squares in 66, so I can leave that be, and I can't cancel 7 and 6 because they have no common factors. Here, with this one, we're going to look at taking care of the square root of 20. So to make that go away, I'll multiply it by itself, and I'll multiply the numerator by the square root of 20. So I end up with 4 square root 20 over 20. Now, the first thing I'm going to do, because I can tell I'm going to need to do some simplifying here, I'm going to look at the numerator, and that's the same as 4 times 4, the square root of 4 times 5. And remember, the secret index is 2, and this is the same as 2 squared, right? So the 2 comes out, leaving nothing behind, and I can't take the square root of 5. It's a prime number. So now, in the next version, I'll have 2 times 4, so that's 8, times the square root of 5, all over, still from here, the square root of 20. I can reduce this farther by saying 8 and 20 are both multiples of 2, so this is 4 times the square root of 5 over 10. And I can still do this. They're both factors there. So that'll be 2 root 5 over 5. And I know that you might be super tempted to deal with this. Don't, because this is under the radical. It has nothing to do with this at this time. And the last one, let's take a look at this. They're both under the radical sign, so I can do some canceling before we get going. They're both multiples of 2, so that's the same as the square root of 3 over 10, the square root of 3 over the square root of 10, right? We're still connecting. I'm going to multiply top and bottom by the square root of 10, and I'll have the square root of 30 over 10. The square root of 30 is, let's see, the factors of 30 are 3 times 2 times 5. None of those are perfect squares, so I'm just going to leave that alone, and I'm good to go. Let's try a couple more. Here, we're going to multiply, and remember the quotient rule says that I can put, since they're both radicals and they both have the same index, I can do this. I can put the whole thing under the same radical sign. Once I'm in that scenario, watch what I can do. I can cancel that and leave behind 1 and leave behind 3, because 3 fits into 3 once and 3 fits into 9 3 times. I can cancel the other way too. 11 goes into that once and twice there. Remember, I can only do that canceling over a multiplication or an equal sign. And you would never have the equal sign under the radical, so that's not an option. So now that I've got it all cleaned up, let's see what it looks like. 1 times 2 is 2. 1 times 3 is 3. That's a lot easier to deal with. So here, that's the same as the square root of 2 over the square root of 3. If I multiply top and bottom by the square root of 3, I'll rationalize that. And I'll end up with the square root of 2 times 3 is the square root of 6 over 3. And again, there's no canceling. That's an illegal move. Here we have 27 p to the 4th over q, and I can do that, q to the 3rd. I'm going to multiply top and bottom by q to the 3rd, because that's really just 1, right? Just like that's just 1. Okay, so let's see what we ended up with. So we have the square root of 27 p to the 4th, q to the 3rd, all over q to the 3rd. There's a secret 2 here in the index, so that means I'm going to look for square roots. So here 27 is the same as 9 times 3, right? So I can pull out the square root of 9 is 3, and it's going to leave behind a 3. Here 2 goes into 4 twice, so I bring p squared out. Actually 2 goes in, so that's going to be completely gone. And 2 goes into 3 once, q to the 1, leaving behind, q to the 1, leaving behind 1, q to the 1. What have I got when I'm all done? Let's see. Outside I have 3 p cubed and q, so I'll end up with 3 p squared q times the square root of, what did I leave behind? I left behind a 3 and I left behind a q. Whoops. All over q to the 3rd. So I can do a little more simplifying here. Let's see. Those will cancel, and my final answer is 3p squared times 3 root q. You can see what I'm saying. 3p squared times the square root of 3q over q to the 2nd. Now, 2 more and we're done. Here, let's see, let's just move this up. This one's pretty basic. We know what to do here. You're going to take the square root of m, over the square root of m, and I'll end up with this. And again, I can't do anything to reduce that. Here, let's see if I can do any canceling before we get started. Because I have x's here, and I have x's there, and I have y's there, and y. Okay, so that'll be good. Let's see what we end up. We have the square root of 10, and x over x to the 3rd y. So that's the square root of 10 times the square root of x cubed y all over x cubed y. Because we multiplied that by that. Make sure when you do this that you bring your radical sign all the way over, because if you don't, then you're not completely telling the whole story. Because there's a difference between and those are two different things. So again, you have a radical in the numerator, but you don't have a radical in the denominator. So that's a really great thing. I know this was a lot of material, but I want to make sure you really get this because this is something that you'll use in your future math classes. Make sure for more practice that you do the U-tries on 563, 564, and 565 and include that work with your prep packet. Okay, and we'll see you in the next video.